My name is Alex Lindsay, and I'm an associate professor in the Department of Horticulture and Crop Science at Ohio State University. And I'm happy to be introducing a review paper that highlights severe storm damage and short-term weather stresses on corn. We recognize that climatic shifts are resulting in more frequent, strong storms and adverse weather events in Midwestern corn environments. In recent years, we've seen a 37% increase in strong storm occurrence in the U.S. Midwest, as well as an increase in overall seasonal precipitation of anywhere from 5 to 15%. This results in wet soil conditions during different times in the year that could affect management decisions like planting date, planting progress, and may lead to growers planting into marginal conditions, especially if they know that a weather front, possibly one that's bringing cold rain or snow, is predicted and could lead to further planting delays. These strong storms and weather patterns are leading to challenges with production and can result in crop damage and yield loss. In many cases, yield losses from severe storms or short-term weather stressors, which we're defining as patterns that deviate from normal for 7 days or less from a duration standpoint, can often occur and lead to questions from growers about how we can better manage corn to minimize these losses or avoid these stresses altogether. This review synthesizes existing literature about 4 main types of stress that can occur as a result of short-term weather patterns or strong storms. These stresses include cold temperature stress, which could be associated with cold fronts early in the season, either just after planting prior to crop emergence, or after the crop has emerged in the case of a late frost event, but also includes events like premature frost prior to black layer formation or the plant achieving physiological maturity. Another type of stress that's highlighted in this review includes corn response to waterlogging or flooded conditions as a result of heavy rainfall. Some of the management decisions that we think about in relation to this stress include management of nutrients, particularly nitrogen, but also how flooding of plants and deposition of soil could affect marketability, particularly for late season events that results in mud on foliage. Another type of stress that's highlighted is hail damage and defoliation, which can often be associated with strong thunderstorms during the summer months. 88% of the hail events in the U.S. Midwest occur at some point during the corn growing season. The final stress that's highlighted in this review is the corn response to wind damage, both during the growing season, from vegetative stages through reproductive, as well as after physiological maturity, but prior to harvest. This review also highlights past events that have occurred of these types of stresses in the U.S. Midwest and highlights what agronomic recommendations and management responses have been implemented to minimize loss. Additional recommendations are provided to help guide farmers and crop practitioners to try and avoid these stressors in the future. Some key findings that are presented in this review are that when these strong storms and weather events do occur, corn yield losses typically have ranged in the past from 5 to 35%, though it is acknowledged that in some cases, greater yield losses are possible, such as when we have 100% defoliation of corn plants during the flowering phase. We also discovered that foundational knowledge on most of these stresses has been produced prior to 1995, and in many cases should be reassessed to ensure accuracy in modern production systems. Many advances in genetic materials available to farmers, precision management practices, and changes in season length and characteristics, such as seasonal weather variability, could alter our fundamental understanding of how corn responds to these strong storm events. Updating agronomic recommendations with modern technology is critical to ensure crop security and to help farmers to understand potential yield losses when these events occur. Thank you for taking the time to watch this video abstract and we hope you enjoy reading our publication, Severe Storm Damage and Short-Term Weather Stresses on Corn, a review that's been published in Crop Science.